session, we'll discuss data communication and networks. We'll first of all try to look at what data communication is, and then what computer networks are. And then from there, we are going to discuss types of network, discuss also the resources that are needed for computer network, and we'll wrap up for today. So basically, you are conversant with what data is, a piece of raw facts that are yet to be processed, whereas information refers to processed data. So basically, data communication is so used not particularly for the transfer of data alone, but for the transmission of both data and information. So data communication is a transfer of data and information from one point to the other using computers and compatible devices. The implication of this is that computers must be involved. Compatible devices could be your mobile phone, it could be your routers, it could also be your maybe tablets, it could be your laptops, it could be a connection of printers and so on that are compatible or connectable to the computer. That's why we say computer and compatible devices. Now, even in telecommunication using your phones, in the mobile phone exchange office, telecom office, there are computers that coordinate the transmission of the calls, the SMS messages you send, the WhatsApp messages, your Facebook chatting, and so on. So computers are the key things that are required in data communication. Then other compatible devices, as I've mentioned. A network or a computer network is a connection or an interconnection of two or more devices to communicate and share resources. In essence, for network to exist, there must be two or more devices linked up together. There could be a phone-to-phone network, like your phone connecting with another phone, either to make call, to send SMS, to transmit data through Bluetooth. Bluetooth is a resource used for transmission or the internet, or to share emails, or to chat on WhatsApp or Facebook or Telegram. Basically, two or more devices must be involved. If two or more devices are not involved, it's not a network. There are varieties of networks. We have road networks, where two or more routes connect to each other. In that case, it's a road network. For instance, from Malabo to the main campus, from the main campus to main gate, from main gate, you go to Etagbo, or you go to Merisleso. These roads linked together are said to be road networks. So when computers and other devices are interlinked like that too, they are said to be computer networks. So we have computer networks, we have mobile phone networks, but all of them put together, we call them networks. But basically what we are concerned with in this course is computer networks, because the computer is the enabler of other telecom networks. Then we look at types of communication. Communication exists in variants of ways. There is that which we call point-to-point communication. In point-to-point communication, you find one system connected to another from one point to the other. For instance, if your phone is directly linked to another person's phone, it's a point-to-point communication. You can share data through Bluetooth. You can also chat through WhatsApp. That's point-to-point communication. Then you have, in point-to-point communication, you may have one unit connecting directly to another unit. Then you have point to multi-point, one point to multiple points. For instance, In this lecture, you are sharing through Zoom connection. The lecturer who is presenting the lecture is at one point, and then the students who have logged in, sharing from the resources of the lecture are in multi-points because you are not aggregated together. A student is in his room, another is maybe in his car, another is sitting outside at the convenience of his corridor using his own device, individualized device. So you are multiple points sharing from one access point. In this case, you call it point to multi-point communication. Then you have broadcasting. In broadcasting communication, there is a one unit broadcasting to multi-users. In point to multi-point, there could be interchange of questions and answers. For instance, students can ask questions on this platform and there will be responses from the lecturer. In this case, is point to multi-point communication. But in broadcasting, there is a sending device, like in the radio station, that will broadcast to various units, where each person has his own private radio, is tuning into that point. TV broadcast, when the presenter is presenting news or casting the news in a TV station, all other persons having their personal TVs link up, and so they listen or watch the broadcast. They don't contribute. That kind of communication is broadcasting. Then you have the simplex communication. In simplex communication, flow or transmission is from one unit, which is the sender, to the receiving unit, which is the receiver. So the sender originates the message and sends. The receiver only receives, it does not send. Let me give you an instance. When you connect your printer to a computer, you form a local network of computer devices. When you connect your mouse to the computer, you form a local network of connected devices. When you connect your speaker to the computer, transmission comes from the computer to the printer and not from the printer to the computer. It is called simplex communication. It is unidirectional. It flows in one direction. That is called simplex. Then we have what is called half duplex. In half duplex, both ends communicate, but alternatively. That's to say they cannot communicate simultaneously at the same time. They alternate communication. For instance, in walkie-talkie, where you see most security men using their mobile devices to communicate, to send signals. Walkie-talkie is an instance of a half-duplex communication system. In half-duplex, when the sender is on, the receiver cannot send. The receiver only waits and receives. By the time the sender is done, you hear them say over. When they make that statement over, it means they are done with sending. Now the person at the receiving end, who was now the receiver, can become the sender, will now be sending. And the person who was the sender in the first instance now becomes the receiver. He doesn't send at that point. It is the person who was receiving earlier that has become the sender that now sends. In that instance, we call it half duplex communication. Then in full duplex, both parties or both devices can send and receive at the same time. An instance is that in your mobile phone communication exchange, you call somebody, the person will say, hello, whom am I speaking with? Say, you're speaking with Joseph. Joseph, how are you? Say, I'm fine. That's to say both of you can both send and receive at the same time. It's called full duplex communication. Now we have to look at the goals of computer networking. Why are computers and other telecom devices networked? The basic rationale or goal for networking is sharing of information and data. Sharing of information and data. For instance, when you are in a network, you can send pictures to your friends, you can exchange greetings, you can send SMS, you can send WhatsApp chats, you can also send video calls and receive video calls, you can send emails, and so on. Now, you can also register for a course online. You can apply for a job online. When you're applying for a job, you submit your data. Your name is data, your sex is data, your age is data, your phone number is data. An aggregation of them put together becomes information, like your certificate, maybe WAEC certificate, which was given to you, informing you about your performance in exam. All of them put together constitute information about you, but each entity is a data item, like your name, your age, your sex, each of them is a data item. So basically, sharing of information and data are the rationale for networking. Another rationale or reason or goal for computer networking is for sharing of hardware and software. Now, let's take an instance of hardware sharing. In a cyber cafe, for instance, or when you visit banks that are networked, you discover that there's a single printer connected to the server. All other standalone computers, they don't have printers connected to them. If each computer was to have a printer connected to it, then the establishment will spend more money in buying printers for each of them. But in a network environment, a printer is connected to the server and all the other units or devices called clients are connected to the server in turn, so that you can sit at the convenience of your bench and send a document for printing, and you just move to the server and bring out the printed document. If several persons send at the time, they are queued up and printed in the order in which they are sent. So that's a basic rationale for networking, sharing of hardware. There are several other hardware devices that can be shared, like scanners. A scanner can be shared in a network too. So software is equally shared. Most times you need to update or upgrade the software on your system. You go online, you connect to the internet, you download the software, you install. You want to maybe troubleshoot your system, you don't have the software hosted in your system, you download it, install it. That's sharing of software. You can share programs. Program that does not exist in your system, you can download it from the network, internet, and install. Then you are sharing, because locally in your system, it was not there. If you are not connected to a network, you will not have access to it. But because you are connected to a network, you are sharing in those resources. Also, you may have written JAM or WAEC or another exam. You don't have the portal installed in your system. But because the services are in the network, you can have access to your JAM result. It is a program that produces your JAM result. So you're sharing in it. You're sharing in that program or software. Another thing is centralization of administration. For instance, I'm administering this lecture to you from a centralized point. You are distributed. So I can coordinate you as if we're in a classroom. We call this a virtual classroom. You are not here, but I'm coordinating, I'm sending you information about this course. I'm giving you lectures on this, on a coordinated platform. So centralization of administration is another rationale for networking. Another instance of centralization of administration is registration of courses. If you register your course on a platform or a portal that has been developed by the institution, instead of going to the department or to the individual lecturer to queue up and register your courses, a platform is developed and hosted on the internet. You use your mobile devices to connect to the internet and you do your registration online. You can print out your document there, and then the administrator can get all your details in the central database without you physically interfacing with him. That is an instance of centralization of administration, and is one of the benefits or the goals of networking. Now we need to look at the basic components needed to establish a network. For you to establish a network, you need several things to put together. Basically, you need a server. A server is a computer that has high processing power, a computer that has fast speed, a computer with an enormous memory to host resources that can be distributed or shared to other devices. For instance, you are privy to participate in this lecture because it's hosted in a server. It is a server that is distributing to you from your various locations. So that computer that hosts the resources that you share, what you don't have in your local device, but you can now connect and share. You are sharing from a server. An instance of a server is a lecturer in a classroom teaching you. The lecturer is the host. He's a server. He's serving you, and you are clients tapping from his resources. So your devices to our clients, they are connected to the server through the network. So without a server, you can't have a network. Then you have workstation, a group of computers that work as if they are the same. They are in the network, but they have some things in common that they share in common, like they are used in hosting database or in processing some specialized documents and so on. We have various types of server. It's not within your scope anyway. We have file servers, we have database servers, and so on. File servers are used in hosting files that can be processed. You have database servers that are used in hosting databases. So there are varieties of servers. You need the server to process what is distributed to others. Then you have the workstation, a class of computers that are on the network that can function as if they are the same, as if they are in the same category. They have the same processing speed, they have the same memory capacity, they work as a group to deliver what is needed. They are called a workstation. Then you have link equipment. It's just like for you to cross from one side of the river to the other side of the river, you need a bridge. Without a bridge, you cannot cross a big river unless you use canoe or you use a ship. You need a speedboat. The same applies to network. For you to connect one or two devices together so that they can communicate and share resources, we need equipment like switches. A switch is a network device that is used in switching or changing signals from one form in one device to another form in another device. The switch, turn this off, turn this on. So they turn signals on and off. They are switches, they are physical devices, they are networking hardware. You also have bridges. Bridges are used in linking one or two local area networks together. Just like the bridge you have across rivers. That's how bridges are used in linking devices so that they can share resources in a network. Two or more local area networks can be connected through a bridge so that the two local networks can now communicate and share resources together. Then you have
this
cables.
one, they have made it worse for people that don't have phone.
Cables in some networks.
Especially
in local area networks. You need a cable to connect your laptop to your printer. You need a cable to connect your laptop or desktop to your scanner. You need a cable to connect one computer to the other within a laboratory, and so on. There are varieties of cables. We have twisted pair cables. We have washer cables. We have fiber optic cables, and so on. So cables are needed in network. Even in the telecom industry, where you see mobile telecom industries connecting, they also need cables in some regions, even though it's wireless. But there are areas that require wires, like in the backbones, where you need heavy traffic of signals. Signals also have weight. That's why you hear of gigabytes, megabytes, petabytes, and so on. These are measurements of the weight of the signals, like graphics, videos, and so on. They carry more weight. Now, there are cables that are laid to transmit these signals to maybe the mast or sending points before they are distributed wirelessly to recipients. So cables are needed to link 2 or 3 devices or more devices together in a network. Fiber optic cables are normally used for backbone. If you're on the highways, most times you see people digging some tunnels and laying some cables. Those are network cables. They are cables linking one region of a network to another, between one town and the other, and so on. So cables are needed. Then we have other network resources like printers. We have network resources like printers. We also need scanners. We need the internet resources. Internet service is mandatory. Without the internet, you'll not be able to hook up to Zoom. You'll not be able to hook up to WhatsApp. You'll not be able to hook up to Facebook. You won't be able to hook up to Instagram, Telegram, and so on. So you must need internet service to connect to the network. We look at types of networks. There are varieties of network types. When networks are localized, they are within a certain geographical region in the neighborhood of 1 kilometer or less. Could be within a laboratory, could be within a building, could be within a classroom, could be within a campus. It is called a local area network, abbreviated as LAN, L-A-N. Local area networks most times could be wired or could be wireless. When it is wired, it's wired local area network. It requires cables, laying of cables to link up the computers and other devices together. When it is wireless, it requires no cables. It can use infrared or whatever, like Bluetooth. Bluetooth is an instance of a wireless local area network. Before you can connect to your neighbor with Bluetooth, you must be proximal to each other. A certain distance is required. If you are too far apart, the Bluetooth signal will not reach. So Bluetooth is an instance of a resource of a local area network. Then within a laboratory or an internet center or a cyber cafe where you find 2, 3, 4 or more computers connected together, you have a printer attached to the server. Somebody will sit on his bench and send a document for printing. Because the printer is in a local area network server, you don't need a printer on each of the computers there. You just send and the computers are connected, the printer is on the server, all computers are linked to the server. Whatever you send from your own desktop or laptop goes to the server, server now sends it to the printer prints it out for you. So that's an instance of a local area network. You find them within banking halls, you find them within laboratories, you find them within cyber cafes, you find them between phones that share resources on maybe Bluetooth, as I've given you an instance. It's a local area network. Then you have the metropolitan area network. Metropolitan is derived from the word metropolis. A metropolis is a city or town. A network of devices, maybe 2 or 3 or more local area networks within a city, within a town, within a metropolis is said to be a metropolitan area network. For instance, if there's a network of computers between Unical and Crutech and College of Health Technology and other associated institutions within Calabar, maybe up to Government House, up to the Naval Barracks, and so on, University of Calabar Teaching Hospital, up to the University Library, up to maybe any bank in the city that has connection with the university, all of them linked together within the same metropolis or town is said to be a metropolitan area network. It is a mini wide area network. It can be a connection of 2 or more local area networks. Then you have a wide area network. When network is wide, it means that it cuts across various geographical regions. Beyond cities, it can be across international boundaries, it can be between states. In that case, it requires more resources. And then you require more money to set up a wide area network. More resources can also be shared with ease. But in a local area network, you are localized, you have limited resources, even though it is most suitable for security of data and information, because it's easy to trace where there's an infringement on security. But in a wide area network, so many persons are connected to it. That is why you hear of internet theft these days. You hear of cybercrime is associated with wide area networks because several persons are connected across geographical regions, USA, Britain, Nigeria, Canada, Cameroon, Ghana, and so on. It's an interconnection of computer resources and other data communication resources across international boundaries. And so it is limitless. It does not fear the barrier of sea or mountains. It's a wide area network. As the name implies, wider connectivity. More resources can be shared, more access to it. Whether it's metropolitan area network or wide area network or local area network, cabling can be involved. If cabling is involved, it is wired. If cabling is not involved, it is wireless. We look at network topologies. The term topology has to do with the arrangement or the organization of the various resources that are connected in a network. A connection, the layout, the manner of arrangement, the architecture of how computers and other resources are linked up to form a network is what is called topology. So we have what we call physical topology and we have logical topology. In physical topology, you can see the layout physically, how the computers are linked up from one line to the other, from one point to the other. You see the manner in which they are laid out, whether they are physically in a ring form, physically in a star form, physically in a mesh form. This is called physical topology because you can see how they are physically arranged. The logical topology has to do with the logic of transmission of signals from one device to the other, from one unit to the other. A system may physically look like a star, but logically it may transmit signals in a different form.
Yes. Please mute your mic. Mute your mic, please. Thank you.
Mute your microphones.
Why?
Okay. So there is a difference between physical topology and logical topology. Physical topology shows how the systems or devices are physically arranged. You can view how they are arranged. It's like the physical architecture of a building, where you see the layout of the rooms, the roof, and all that. The same applies to computer network topologies. When they are physical, it means you can physically see the manner in which the devices are arranged or organized or linked together. But in logical topology, you cannot see the order physically, but the transmission of signals is in that format, maybe in a star form, in a ring form, in a bus form, in a mesh form, as the case might be. So one of the topologies is bus topology. In a bus topology, the topology is the simplest of all topologies. It requires cables linking two or more computers together in a small area, and it requires stop points, terminators, so that signals cannot bounce back from one point to the other. So a bus is the simplest topology. It requires cables that are laid from one point to the other, connecting one device to the other. You find bus topologies predominantly in local area networks, maybe within laboratory, within a cyber cafe, and so on. Cables are laid to link the resources together. So we call that bus topology. Then you have the star topology. In star topology, there is a hub, a controller in the center that connects the devices together in a starlight manner. The hub is sometimes called a concentrator. It transmits signals to all the other components of the network. So we call that the star topology. In the star topology, various computers can also be linked to form what is called a hybrid star. That is to say, a hub can serve as another hub to another, linking various computers together in order to allow them to share resources. Apart from the one tapped from the main hub, several other hubs can also be linked up together. Then you have the ring topology. In a ring topology, you need what is called a token ring. The signals travel in a ring-like manner in one direction, not in both directions. So if a signal is transmitted from computer A to computer B in the ring, if the message is not meant for computer B will pass it on to computer C. It will check the address and see whether it's meant for it. If it is not, it passes it next to the next device until it gets to the destination address. Then action can be taken. So there's what is called a token ring. A token ring can spin through the ring up to 1,000 times per second. 1,000 times per second. You can imagine the speed. So we call that ring topology. Then in a mesh topology, every computer is connected directly to another computer. It doesn't need to pass resources through the hub to transmit or redistribute, or it doesn't need to pass the resources through the mesh. Each device has a direct access to the controlling device, which means communication to all is broadcast at the same time and receiving of signals to the same time, responses at the same time. Each unit, each component has direct access to the controlling device. That's what is called a mesh topology. It is more costly to set up, and then troubleshooting of problems is also complex in a mesh topology. Since all computers or devices are connected to each other, it means that it requires more cabling if cables are used, and then it requires more access cabling if cables are used, and then we have network devices. For computers to be connected together and telecom devices, we need computers themselves connected. Computer is the primary device. We need a modulator and demodulator. Modem. We need the modem will convert signals from modem analog to digital form in the original digital term, and then maybe from digital back to analog in the receiving digital back to analog, called a modulator. Modulation is the process of initial conversion, maybe from modulation to analog, from analog to digital, and then modulation is the reconversion to its original form from the receiving form. We call it modem. Then we need a hub. I mentioned the role of the hub in the start of I mentioned the role and distribute other systems in the network. Then we have cables. I mentioned cables, coaxial cables, twisted pair cables, fiber optic cables, or wires. We need switches. I mentioned switch earlier too. We need switching signals from one unit to the other signal. Then we have repeaters. Repeaters are used as amplifiers so that signals do not degenerate in strength. Because signals degenerate when they travel over a long distance. Because we call that attenuation. A reduction in the strength of the signal as it travels through a length of the region. For instance, if you're listening to somebody's voice from afar, the voice, if you're listening to somebody's faint from afar, you are closer, it sounds louder. So when a repeater is used, it's just like an amplifier that is used in a microphone. When a repeater is used, it amplifies the signal, the microphone, repeating the strength of the signal so that it doesn't begin it. Then we have network interface cards. In your computers, in your network interface card, desktop or laptops, you have inbuilt network interface card. That is where you have connection between one system to the other. That is where connection is achieved. Without an interface card, your system cannot interface or connect without an interface. In fact, in a wired network, you have a slot where the wire enters into the other device. That is the interface card. That is slot with the exit point where the wire enters. That is the interface. Then you have the router that is used in routing signals from one region to the other. Then you have the router from one. Then we have what we call the client-server architecture. I passively mentioned this. In a network, we have what we call the server. We have what we call the client. The server. In a network, we have resources, the services, the data, the information that for instance, when you are given an assignment and you go online, the data, the information that topic, for that topic is already hosted in the server, and you go your system that you are using in connecting to download is called the client. That topic is already hosted. The server provides the resources that the other devices connecting to download the network. Called the client. Other devices that tap from the server access to the clients. For instance, other devices that tap. If you liken it to the lecture we're delivering here, the lecturer is a server, the students are the clients. If you liken it to the law profession, the person who has a case that contacts a lawyer is said to be the client, while the lawyer who is the solicitor is the server. So it has application in various domains. In the computer parlance, we are referring to computer resources. We have programs that are servers, and then we have hardware that are servers. We have programs or software that function as servers, and those software that host the resources or process the resources that are distributed to the other devices or other programs. And the physical servers are the computers, fast speed computers, large memory computers, high processors that can render computers, large memory computers, high processors network that can. Thank you. See you next time.